Hi, my name is Veronica, and the title of my research paper is Assessing Small Wind Turbines for Everyday Homeowners. Okay, so basically about the research idea, my mentor Reagan actually studied environmental engineering, and that was a major that I was considering. So we thought that it would be a great idea to go the renewable energy route, and she suggested that I should try answering the question, what is the best low-cost wind turbine for an everyday homeowner using a skill score sheet, which I learned was common in engineering project management. So I thought that this was a great idea to learn a new skill that I might use in the future and also learn more about renewable energy. So these are basically the steps that I took from the beginning to the end of my research project. I first had to learn, or I first had to understand how wind turbines work, and I used all of that information for my introduction. And then I had to find a region that had a relatively high wind density so that I can use that, so that I can base my data on that region, and then collect data, which I'll explain later, and then organize all of my data and evaluate them in my results discussion and conclusion sections. So for my introduction, I basically just explained what the research paper is on, and it's about 6 small wind turbines being evaluated by their performance, cost, and user friendliness. And I also stress the importance of this topic, especially since we're seeing the negative effects of using traditional energy sources like coal and oil. Climate change is getting worse, and I'm seeing a lot of scientists protesting, and you can really see that they're fearing the possible consequences that might occur soon. And so many are suggesting the move toward clean energy, and wind is a free energy source that can provide clean energy. So I thought that researching wind turbines would be a really good topic, and small wind turbines can actually provide energy independence. Since it's small, it won't require as much land as establishing wind farms. So yeah. For my introduction, I also thought it would be important to explain how wind turbines work. So basically, wind makes the rotor blades spin, and then once the blades spin, a shaft inside the nacelle will turn, and that shaft will turn another shaft, and that'll eventually reach the generator. And when the generator is powered, it will send electricity through an electrical grid. Like I said, I had to pick a region. So I used Global Atlas to identify a region that had a relatively high wind density, and I ended up choosing San Diego County, California, which I thought was cool because I lived in California too. For my method, I use SAM, or System for Award Management, which is a graphic user interface that basically has a large database for renewable energy. It had a lot of information on wind turbines and solar panels. So I use SAM's data for Southern California mountainous region to cover the San Diego County region that I picked. And I also used it to find the turbines that I evaluated. So I chose the X Series, Skystream, Travier Industries, Hummer, Zephyr, Air Dolphin, Burgie, Kingspan, Proven. And then Sam also helped with finding the data for some of the categories that I use in my skill score sheet, like power rating, rotor diameter, annual energy output, and power graphs. And then I had to Google companies' websites, turbine manuals, and studies that involve the turbines to identify the data that wasn't offered by SAM. So to provide more details about the 6 turbines, I use SAM and Google to create a table of the specifications and images of all 6 wind turbines, like their power rating, rotor diameter, the number of blades, some of their tower heights, but for some it depends on the location, their wind speeds, and yeah. For the second part of my method, this is when I organized all of the data that I found into a skill score matrix, and these are the areas that I evaluated them on. So power rating. Power rating is basically the amount of power that a wind turbine will accumulate, and yeah, rotor diameter is basically just the diameter of the rotor. Swept area is the area that that is captured while the turbine spins, and annual energy output is basically the amount of energy that the turbine can produce. And then cost, source location, availability, maintenance frequency and maintenance steps, user installment steps, and user ratings. So this is what my skill score matrix looks like. And as you can see, these are all the categories. And at the bottom, it's the same categories, except for the numbers, they're basically the scores. For the scores, I scored them based on how much information was available. And also I thought that some of them were more important than others. Like I thought annual energy output was more important than cost, because I think it would be better to have a wind turbine that can actually sustain more power, even if it's a little bit more expensive than buying a cheap one that can't really do anything. And for this one, for figure 1, I used Sam's uploaded power graphs for each turbine, and I just combined them to compare the turbines and their power ratings. And I also used this to explain why power ratings didn't score as much, since it's not very consistent. As you can see, it takes a specific amount of wind speed for each turbine to reach that peak or the advertised power rating. And these are my results. So after adding up all of the scores, I was able to create a bar chart, and I found out that the Kingspan Proven scored the most with 23.5 points, and the Hummer scored the least with 15 points. For my discussion, I basically explained why some scored better than others. And like I've already mentioned, the categories varied in score based on which one was deemed more important. Like I said, annual energy I thought was more important than cost because of cost effectiveness. I think it's better to invest a little more money to something that can sustain more power. And also my method of research encountered inadequate information, and that led to some zeros in some of the scores, especially user rating, because not a lot of people rated the wind turbines. For my conclusion, I ended up recommending Kingspan KW3 as the best option for a low-cost wind turbine for the everyday homeowner, or SD3, since Kingspan wind turbines have been bought by SD Wind Energy. And like I said, I did encounter some limitations, and this is just expanding on it. Many of the sources that I found from Google were from over 10 years ago, probably because a lot of the turbines were released over 10 years ago. And some of the information came from old studies, since it was difficult to find the manuals and costs, and some of the information were just simply unavailable. The data from SAM was kind of fixed. It was based on a hub height of 80 meters, and hub height is basically the height from the ground to the middle of the rotor. And I think it would have been better if I could have been able to experiment with different heights, especially since I was assessing small wind turbines. And in the end, I stated that future research on this topic is encouraged and can begin by expanding lists of turbines, by maybe including newer ones that weren't from over 10 years ago, and also having a longer time frame reserved, since a lot of the turbines companies require you to contact them to get a quote for the cost, or just like more details about the wind turbines. And basically that's it. I would like to thank my mentor, Reagan McKenney, who's a PhD student. She helped me with everything from finding a research topic to finding resources, and also for editing my research paper, which I knew was a lot because it was my first time really writing a scientific paper. And also I would like to thank Talaria for giving me this opportunity to write my own research paper, which I didn't think was possible for me. And it really gave me direction in what I wanted to do in the future, because coming in, I was really lost. And now I realized that I enjoy researching, and I kind of want to do something with renewable energy and making the world more sustainable.